So welcome everybody. I am Doug Schmidt. I will be giving today's lecture, and I'm going to be talking about a bunch of different topics related to generative AI, particularly as how it's applied to software development and the use of various AI techniques in both building software as well as building systems that use AI. I'm going to channel my inner Socrates, who once famously said, "The unexamined life is not worth living." My paraphrase of that is, "The unrecorded talk is not worth giving." And so I'm going to be recording this video, and I'll post it on YouTube so you can watch it later if something goes by a little faster than you might like. So the talk is broken up into three parts. We're going to start out by talking about assuring the future of software engineering and AI engineering, and I'll talk about what I mean by those things. In particular, we're going to talk about ways that we can develop systems using AI-augmented software development lifecycle techniques. This is how the tools that we might use to build software. And we're also going to talk about AI-augmented systems that are built using conventional techniques, but they run with AI-enabled capabilities. And we'll talk about all those things in just a second. You can find out more about some of these ideas at this link. There's a study that was published a year or so ago. We'll talk more about this in a second, that talks about many of the different ways that AI is going to make a difference in the way that we build software systems and we operate software systems. So this study, which came out in November of 2021, was designed to try to get people excited about the next generation of ways we build software. Tools, processes, programming languages, platforms, methods, and so on. And we were really trying to set up a research roadmap to tell people how things might go in the future. And this was work that was sponsored by the Defense Advanced Research Projects Agency, the National Science Foundation, as well as my colleagues from the Software Engineering Institute, where I've worked for about 20 years on various projects. There were 6 main topic areas that we covered in this report. I'm not going to go through them in detail here. I'll just point out that in the famous words of Yogi Berra, predictions are hard, especially about the future. So when we start trying to look down the road, it's sometimes difficult because we're not quite sure what's going to come, and we don't know when it will come. And that's the particular point here. So when we did this study a couple years ago, our horizon was 10 to 15 years out. Then from that point of view, thinking 10 to 15 years out, we recognized that within that time frame, 10 to 15 years, the current way that we build software systems, which is very manually intensive, a lot of people using programming languages like Python and Java and JavaScript and C# and C++ and so on, that will be replaced over time by people working together with artificial intelligence or some variant of artificial intelligence as trustworthy collaborators so we can more rapidly build systems based on the design intent of the people, the customers, the end users, the stakeholders, the programmers, the managers, and so on, rather than having to program it all by hand the way we mostly do it today. Well, then something fascinating happened. Exactly 1 year after we released that study, ChatGPT escaped from the lab. So about a year and a couple months ago, November 2022, ChatGPT was released onto the unsuspecting world. And unless you've been frozen in carbonite like poor Han Solo, you probably know that ChatGPT is an example of generative AI. It's a large language model that's designed to be able to synthesize new and original content in a conversational manner. And you guys have probably already worked with this quite a bit, so you have a good idea of what I'm talking about. Just for fun, I used one of the new AI tools called Runway Gen 2 to generate an image of Sam Altman, who is once again the CEO of OpenAI. And I said, because remember, if you've been following the news, about 2 months or so ago, Sam Altman was temporarily ousted in a coup, and they got rid of him. But I said, please generate Sam Altman as Obi-Wan Kenobi, who became much more powerful when he was struck down. So this is what was produced. And I thought that was actually pretty clever, pretty good. It looks kind of like Sam dressed up as Obi-Wan. When this happened a year or so ago, a lot of people predicted the end of the world was at hand. If you want to amuse yourself, Google, "Is AI the end of the world?" and you will get all these articles that talk about there's a damn good chance AI will destroy humanity. What is the AI apocalypse going to look like? Are we doomed? Should we stop developing AI for the good of humanity? And in the immortal words of Ron Burgundy from the comedy movie Anchorman, boy, that escalated quickly. Now, what's my perspective on this? Is the world really coming to an end as a result of generative AI? I think there's a lot of things you should probably be a lot more concerned about being the end of humanity as we know it than generative AI. Perhaps the black hole that's moving slowly towards Earth to suck us into its forces. Probably more likely nuclear war breaking out because Russia wants to subjugate Ukraine. Something near and dear to my heart, too much TikTok. Much more likely to rot the minds of people in this country faster than generative AI, much more lethal in many ways, the addictive properties of this. Now, if generative AI really is the end of humanity as we know it, and it's going to occur soon, a lot of the discussions we're having about what's going to happen 10 to 15 years down the road are probably not worth having. However, if we take a more optimistic view, we should take our guidance from a classic Stanley Kubrick movie that was released back in 1964. It's hard to believe it was just about 60 years ago. It was called Dr. Strangelove. And the tagline from that movie was, "How I Learned to Stop Worrying and Love the Bomb." And the reason that that movie was popular then was we lived in the shadow of nuclear war with the Soviet Union at the time. And so people were very paranoid about a lot of things. So riffing off of that, my new perspective is I want to learn to stop worrying and love the bot, the chat bot, because that's likely to be something that will give us a lot of guidance and a lot of help and a lot of frustration, perhaps, down the road. So when we took a look back at the study we did back in 2021 and took into account what's happened, we decided that we were going to re-examine the impact that AI was going to have. Now, the original study, if you are interested in take a look, you'll find that two of the focus areas in the study looked at AI. One of the focus areas looked at the AI from the point of view of how AI will help augment the way we build software systems. And another focal point was on how we would engineer AI-enabled systems, in other words, systems that used AI at runtime. And I'll talk about both those different paradigms in a second. After we thought more about this and we spent a lot of time really focusing in on what AI does, how do large language models like ChatGPT work, other models like Anthropic's Claude, Google's Bard, and so on and so forth, we actually came up with a newer and better way to look at the future of applying these technologies in the context of software. And you can read more about this at a blog that's available at this link. I'll put the slides on the website too, so you can click on the links that'll be in the slides. So we decided there were really four dimensions it's a fourfold table with two axes. The axis that's the x-axis is the degree of AI augmentation in the software development lifecycle. That's, do we use AI to build software? And degree of AI augmentation for operating the system. In other words, is it AI enabled or not? So let's take a quick look at this and give you a level setting of how to think about this space. It's probably fair to say that 99% of software systems built today are conventional systems built without using AI in their development, and they don't really use much AI in their operations. A good example of this, which I have a lot of experience with from the research I've done here at Vanderbilt and also at Washington University in St. Louis, also at DARPA, other places, is avionics mission computing systems. Avionics mission computing systems are responsible for making sure that airplanes get where they need to go and carry out their missions successfully. These kinds of systems historically have been safety critical, mission critical, real-time embedded systems where the right answer delivered too late becomes the wrong answer. And they have historically been built without using any AI whatsoever in the software development, and they don't really use much AI in their operations. There's getting a little bit more AI in some things like target recognition and so on, but historically these have been very deterministic systems. That's the way most systems exist today. However, with the advent of AI-augmented tools, and we'll talk about a whole bunch of them here in a second, things like code reviewers, code generators, coding buddies, various tools that can do testing, it's now possible to start to build software using AI-augmented software development lifecycle tools, methods, platforms, languages, and so on. And we actually do this at Vanderbilt. If you have a chance to take the courses I teach here in the computer science department, we do a lot of this. And you can actually take a look at this link, which explains how we do that. So we'll talk a bit more about that. At the other end of the spectrum, there's also systems emerging today, YouTube being one of the prime examples that you probably use quite a bit, that use AI to run. Now, they probably weren't built with a lot of AI-enabled tools because they've been around for a while, and those systems predate the advent and the broad use of AI-enabled tooling. but they use AI-augmented techniques. So a good example would be a recommendation engine. YouTube, of course, has, as does Amazon, as does lots of other things these days, that employs machine learning for customizing recommendations, trying to convince you what you should go out and consume and purchase. However, these systems are built in conventional ways, typically using agile methods, which you hopefully will get a chance to learn about too. Of course, the holy grail of all this is AI-augmented systems that use AI, built with AI-augmented tools. Now, this is just beginning to happen, so there's not a lot of examples to point to yet. One thing that is an obvious candidate for this would be self-driving cars that use machine learning algorithms for navigation, vision, decision-making, and are built with AI-augmented DevOps tools for development, testing, deployment, and so on and so forth. And these are things that we continue to talk about in various contexts, including this blog at the Software Engineering Institute, which I started about 12 years ago when I was the Chief Technology Officer there, and has continued to be very popular over the years. One of the things you've undoubtedly noticed, because you've been using these tools or starting to use these tools, is the barrier to entry is incredibly low. So you can go to websites like the chat.openai.com, Claude.ai chats. There's stuff coming out for Google with Gemini. You can use Bard. Bard's a little crufty, doesn't really get you where you want to go yet. But there's a bunch of stuff emerging. There's a bunch of open source models. And it's really simple to get started. In fact, for the price of 3 cups of expensive pumpkin spice lattes or whatever at Starbucks, each one costs about $7, you can get a subscription to a lot of these services, so you can get access to the plus versions, to the advanced versions, which contain lots of features that are much better than the ones you get off the shelf that are free. However, because it's so easy to use these tools and technologies, it's very important that we set our expectations correctly, especially given the fact that they've only been around for a very short time. There's been a number of articles published by well-respected computer scientists and engineers who are prognosticating, based on a very limited sample of experience, where the world is going. And here's a good one by Peter Denning, who's a professor. I think he's at George Mason University, or was. And he says, I've noticed a certain style to many of the ChatGPT documents I've read. Most of what it tells you seems like you've already heard it somewhere. There's no radical departures from what others have already said. It has frequent excursions into nonsense. It speaks with great authority, even when outputting nonsense. What does that sound like? That sounds like me in my first semester as a PhD student. I didn't really know what I was talking about at that point. I was learning. I would often spout nonsense. I was very confident that what I was saying was good. But the point there was that nobody expected me in my first semester, first few months, to write papers to be published in Science and Nature. People didn't expect me to write competitive grants for the National Institute of Health or DARPA or the NSF. Instead, my mentors worked with me, and we iterated and refined, and hopefully I got smarter and became better at what I do. So when you think about these tools that have been out for a short time, especially when a lot of these articles were written, where they were written back in like a year ago, when this stuff had been out a month or two, we really have to have the right expectation. Things change very fast, and tools that were spitting out nonsense a year ago are being much, much more precise and trustworthy. I won't say they're trusted, but they're getting closer, especially if you use them properly. So for the time being, because these tools are not fail-safe or foolproof, we're better off thinking about augmented intelligence rather than artificial intelligence. So I call that, we've phrased the term AI plus. And the idea here is we're going to augment, not be artificial, and we're going to supplement, not supplant. So we are in the loop. Humans are involved. As long as you take that perspective, life is really good. And in fact, I suspect most of you are doing things like that. Hopefully you're doing things like that when you use tools for your work, for this class, for other classes where generative AI may be handy. And the way I like to envision this is like an exoskeleton for your brain. If you're familiar with Professor X from the X-Men movies and comic series, he had this device, I think it was called Cerebro, he would put on his head, and using that he could see further out into space and he could track things. That to me is what augmented intelligence is all about. It's about making us more effective. And when used properly, and we'll talk a lot about what we mean by used properly, it can do wonderful, amazing, great things. So that's just a quick overview of the first part of this discussion, just to give you a sense of where I'm coming from and some of the things we're going to talk about. What we're about to talk about are those two dimensions of using AI-augmented tools to build software and the impact that's having. And then we're also going to talk about AI-augmented systems that use AI in their runtime operations.